Welcome back to the Deep Dive, where we take your sources and cut straight to the core of what really matters. Today, we're putting on our material science goggles because we are looking at a genuinely surprising advancement in, of all things, golf equipment.
That's right. We are diving into Mizuno's 2026 driver face technology. And this isn't just, a new paint job for a new model year.
Yeah.
This is chemistry, it's physics, and the source material makes a really bold claim.
It does.
It says this is a fundamental shift away from conventional single material faces.
Okay, so that's our mission then. Let's figure out how adding a tiny nanoscale layer to titanium can actually change performance so dramatically.
And do it while staying totally legal. That's key.
Absolutely. So let's unpack this. We're talking about a forged titanium club face, which is, that's the industry standard.
The gold standard.
Right. But now it's combined with this invisible layer, a nanoscale polymer alloy. It sounds a little like marketing fluff, doesn't it?
It does, and you'd be right to be skeptical, but the sources are insistent. This is structural, not superficial.
Because it's not a cosmetic coating.
Absolutely not. They go to great lengths to emphasize that. This polymer is integrated at the molecular level, an ultra-thin layer that literally bonds with the titanium to change how it behaves.
Okay, so Mizuno isn't replacing titanium. They're enhancing it, giving it a sort of dynamic assistant.
That's a great way to put it. The polymer acts as what the sources call a dynamic energy mediator.
The dynamic energy mediator.
Yeah. And that leads us to the core concept here, which is adaptive elasticity.
Adaptive elasticity. That sounds like the face is thinking for itself. A smart material.
That's a perfect analogy. It's less like a solid wall and more like a smart shock absorber.
So its properties change.
Exactly. Under low stress, just sitting there, it's stable and firm, totally rigid. But at the moment of impact, with that huge localized force, the polymer alloy kicks in and it instantaneously increases the local elasticity right around the impact zone.
So it's not the whole face getting soft, which would kill ball speed on a good hit.
Precisely. It's targeted. It's intelligent flexibility, only where and when it's needed.
And what does that mean for the golf ball?
It means a more efficient energy transfer. Because the face adapts so well at that molecular level, less energy gets wasted just, squishing the ball.
Okay.
So the face absorbs and releases that deformation more efficiently, and more of that energy goes back into the ball as velocity.
Which is the name of the game. Higher ball speed.
That's it.
But isn't there usually a trade-off? If you make something more elastic, you usually lose some durability, or maybe the feel gets mushy. Golfers hate that.
That's a critical question. And the achievement here is that the polymer also acts as a structural reinforcement. So while it's managing the rate of deformation, it's also adding strength.
So that allowed the engineers to do something else.
Yes, it unlocked a huge practical structural advantage.
Okay, let's jump into that. From the molecular science to the actual engineering, what did this new material let them do?
Well, because the polymer reinforcement made the whole structure stronger, they could take a risk they couldn't before.
Which was?
They could make the face thinner, significantly thinner, in critical areas, without worrying about it breaking down over time.
How much thinner are we talking? Because in driver design, every micron counts.
The sources specify about a 10 to 11% reduction in thickness.
10 to 11%. That's a massive change in tolerance.
It's huge. You're getting a thinner face that's just as durable, if not more so, because of that nano-alloy structure.
And a thinner face is the key to forgiveness.
Yeah.
Right, that's what everyone is chasing.
Exactly. That thinness is what allows for a larger, high rebound area across the face. But they have to be careful.
With rules.
With the rules. We have to talk about characteristic time, or CT.
Okay, let's define that for everyone. What is CT?
CT is basically the legal speed limit for a driver face. It measures how long the ball stays in contact with the face at impact. Too long, and the face is acting like a trampoline.
And it's illegal.
And it's illegal. So every company is trying to design their drivers to get as close to that maximum legal limit as they possibly can.
Just kissing the line.
Right on the edge. And what's so interesting here is that this thinner, stronger face lets them push that maximum CT limit, not just in the dead center,
The sweet spot.
but across a much wider area of the face.
So they're not just making the sweet spot hotter, they're making the whole neighborhood hotter.
That's a perfect way to put it. It leads to more consistent ball speed when you don't hit it perfectly. The sources specifically call out better performance on heel and toe impacts.
Which is where most of us live.
Right. They've expanded that effective rebound zone, which means more forgiveness, all while staying perfectly legal.
Okay, so the science is there, the engineering makes sense. But what about the results? Did the testing actually show people hitting the ball faster?
Yes, and this is the bottom line. It's not theoretical. The data from both robots and, more importantly, from real players showed measurable gains.
And I'm guessing those gains were biggest on the mishits.
Exactly, reinforcing that whole forgiveness story.
So give us the numbers. What kind of a speed bump are we talking about here?
Compared to their older all-titanium models, the testing saw gains of about zero point 0.5 to 1.0 miles per hour in ball speed.
Half a mile to a full mile per hour. Now, that might not sound like a lot to some people.
But to a golfer, it's a huge deal. 1 mile per hour can be 5, 6, even 7 more yards of carry distance.
That's the difference between being in the fairway and being in the bunker.
For sure. It tightens up your dispersion. It's not just about more power. It's about minimizing the penalty when you miss the center.
It shrinks the variance?
Precisely. And what's really interesting is that the sources say this effect is especially noticeable at moderate swing speeds.
Oh, really?
Yeah, this tech really helps the average player, the person swinging, 95 to 105 miles per hour, keep their speed up on those slight misses.
So it's not just for the pros. That's a huge part of the market.
A massive segment.
Now, what about launch and spin? A lot of faster swingers are always trying to get their spin numbers down.
Right, and that's a critical point for fitting. In its standard setup, this design actually generates slightly higher launch and moderately increased spin compared to some of the super low spin heads out there.
Wait, higher spin is a good thing. That sounds counterintuitive.
It does, but think about that target player again. For a lot of golfers, the real enemy is too little spin.
The ball just falls out of the sky.
Exactly. It can't stay airborne. This moderate spin helps maintain stability and maximize carry distance. It's about optimizing your total distance, not just chasing a few extra yards of roll.
That makes perfect sense.
Yeah.
So let's nail it down. Who is the absolute ideal golfer for this technology?
I mean, based on that performance profile, it's for the player who prioritizes consistency and forgiveness over just, the absolute lowest spin number possible.
The moderate to medium fast swingers.
Yep. If you want forgiveness without giving up speed, this enhanced elasticity is really designed for you. I mean, who hits the center every single time?
Nobody I know. So let's talk about the products themselves. How is Mizuno bringing this to market?
They're smart about it. They're offering 2 different driver platforms.
Okay.
There's a standard high-stability head that's all about maximizing MOI. Classic straight-line forgiveness.
Emma, the second one.
Is a more compact performance head. That one is designed with a lower spin potential for the faster player who needs to manage that.
And I assume they're both adjustable.
Oh, absolutely.
Has to.
Full adjustable locked and lie systems. That's mandatory in the premium space. You can fine-tune your flight without changing that core behavior of the face.
And the big question, the price. Where does this sit in the market?
The recommended retail is €599.
Okay, so firmly in the premium category, right up there with the other flagships.
Exactly. They're positioning it as a top-tier performer, and they're justifying it with this fundamental change in the material science.
So let's bring it all together. What is the single biggest takeaway for our listeners?
The conclusion from the source material is pretty clear. This nano-alloy reinforcement is a genuine material science advancement. It's not just marketing.
It's delivering real gains.
Measurable gains in consistency, forgiveness, and ball speed retention. By changing how the material behaves at the nanoscale, they solved an old engineering problem: the conflict between durability and rebound.
It's just fascinating. That's something you can't even see. A molecular layer is what unlocks these performance gains. It's the ultimate lesson in precision engineering.
It's that marriage of brute strength from forged titanium with the surgical precision of this dynamic polymer. That's what's making the difference.
And that is our deep dive. Thank you for walking us through that amazing blend of science and sport.
My pleasure. But before we go, here's a final thought for you to chew on.
Okay.
Given that this tech relies on controlled elasticity through molecular bonding to handle a high-impact situation, think about other applications. What other non-golf areas, like, say, aerospace materials or even protective gear, could benefit from combining a strong metal foundation with a nano-scale adaptive polymer?
That is a big thought to mull over. Maybe on your next tee box. Thanks for joining us for the deep dive.
See you next time.